Okay, if you remember from last section, I said this whole chapter is basically undoing everything we did from last chapter. So last chapter we multiplied binomials together. Now we're going to undo that and factor them out. But before we can do that, we do have to review how to multiply polynomials. So remember, we are using the distributive property. We're just distributing that x through in order to get x squared plus 7x. Then we have to distribute the 2 through in order to get 2x plus 14. Okay, if you remember, we always combined those two middle terms. This is the outside and the inside term. So if we combine 7x and 2x, our final answer then would be x squared plus 9x plus 14. Okay, and I'm going to have to get those out of the way because we need to see those numbers after a second. Okay, so let's go ahead and look at 2, and then we're going to stop and see something, hopefully. Again, we're distributing an x through in order to get x squared plus 3x. Then we're going to go ahead and distribute a 4 through in order to get a 4x and a 12. Okay, combining those middle terms, we end up with 7x, and then we end up with 12. So let's go ahead and look at, first off, making sure I know how to transpose numbers. Okay, let's go ahead and look at the relationship between these two numbers down here and what we had up here. Realize that we're always adding those two middle numbers together. So this 9x is always adding that 7 and 2 together. This 14 is multiplying those two numbers together. So our outside term are the two constants multiplied together, and the inside term are the two constants added together. Okay, is that the same as this second one? Did that work? Okay, we have 4 and 3. 4 times 3 is 12, and 4 plus 3 is 7. So when we look at our trinomial comes out to be, again, we see that there is a 4 and a 3 in common right here, and a 4 and a 3 in common right here. So when we're factoring, we still see that factor of 4 and 3, but they have to be special factors, because I know other factors of 12, 6 and 2, but 6 and 2 do not add up to be 7. 4 and 3 add up to be 7. So again, when we're undoing it, we're looking for that pattern. We're going to ask ourselves, what times what gives us 12? And added together gives us 7, because those are the two constants that we're going to use in our binomial. Okay, I digress. Let's go ahead and look at this last one. See if that's the same, even if we have a negative sign in there. So x squared plus 3x. I'm going to distribute that negative 4 through. Negative 4x minus 12. Let's see what we get. Again, we are still adding those two middle terms. So I end up with x squared minus x and then minus 12. Well, does that work? Again, negative 4 plus 3 is a negative 1, and negative 4 plus 12 is a negative 12. So that does work, and realize why that works. So when we're factoring, binomials now are a little bit different, because we can't look at, when we look at an x squared plus 7x plus 12 and try to factor that, not all three of them do have something in common. But again, we understand that multiplying two binomials together is going to give us a trinomial. So we have to look at the clues of the numbers, that constant and that middle term. We're looking at those clues, knowing that the two constants that we're going to use multiplied together give us 12, added together give us 7. Okay, so again, with those concepts in mind, we're supposed to factor those. And we're going to write this out as a question so we understand what question we're trying to answer. When we are factoring a trinomial with no number in front of the x squared, we are asking ourselves, what two numbers when multiplied together, come on, let go, are 12, because the outside term is the one that's being multiplied, and added together are 8. That's the question we're asking. Okay, that's in a nutshell, in words, that is what this polynomial is asking. So what two numbers multiplied together give us 12, added together 8? One way to look at this, instead of that question, we can go ahead and write down the factor, and then we're going to write the sum of those factors. So let's go ahead and start thinking of factors of 12. Well, I know 1 times 12 is 12, but the sum of the factor, our goal, we want to be 8. Okay, 8 is our goal number. Well, 12 plus 1 is 13. So that didn't work. Well, I know 2 and 6 multiplied together to give me 12. Well, what's 6 plus 2? 6 plus 2 is 8. So there it is. So what two numbers when multiplied together give us 12 and added together give us 8? 6 and 2. So with that, we know that we are going to have two binomials. Our first term is going to be x, and this is the reason why. X times x is x squared. We're going to have a positive 6 as one of our constants and a positive 2 as our other constant, because 2x plus 6x give us 8, and then 6 times 2 give us 12. Okay, so we're looking at the clues inside that polynomial and then thinking in our minds that question that it's asking, and then we go ahead and factor. Okay, so technically those three terms have the binomial x plus 6 and x plus 2 as factors. So still same question here, and now we're dealing with different numbers. What two numbers when multiplied together give us 35 and added together give us 12? Again, one of the best ways, unless you're really good at factoring, we call it F and S. So again, these are factors, multiplying, and then the sum of the factors. So if you don't know where to start with 1. 1 times 35. Well, then we add those two together. 35 plus 1 is 36. Doesn't work because remember, our goal is that middle term. We want our sum to equal 12. Well, 2 doesn't go into 35, 3 doesn't, 4 doesn't, 5 does. So 5 and 7 are factors of 35, and then the sum, 7 plus 5, is 12. There we go, we found him. Okay, so what two numbers, whoops, yeah, I got that. What two numbers when multiplied together give me 35 and added together 12? 5 and 7. So again, we're going to set up our two parentheses. We know our first term is always going to be x because, again, x times x is going to give us that first term of x squared. And then we know our second one is going to be a 5 and a 7. So if you need to kind of keep, that's why I was second guessing looking at this. If you want to, you can say factor and then put your goal there. My factor is 35. Okay, multiplying together I need 35, added together I need 12. How am I going to do that? I'm going to use 7 and 5. Okay. Having two positives, pretty simple. When we start dealing with negatives, it's a little bit trickier because we have many different options. So again, what times what multiplied together gives me negative 18, but added together gives me a positive 3. So here's where it gets a little bit trickier. Okay, again, we're dealing with factors. So multiplied together and added together. Factor, I need a negative 18. Sum, I need a 3. Yikes. So let's go ahead and try this. I'm going to weigh out 1 and 18 because I know that whatever that is going to be much bigger than 3. So let's go ahead and try 2 and 9. Well, one of them has to be negative. So I'm going to try -2 and +9. Then I'm going to try a +2 and a -9. -2 plus 9 is 7. Didn't work. 2 plus -9 is -7. Didn't work. So what's next? And again, notice what I'm doing. I took 18 divided by 1, knew that was too big. 18 divided by 2, that did have a nice integer. 18 divided by 3 does as well. So again, if you're not very comfortable with factors, just start going down the line and dividing by numbers. So 3 and 6, right? And again, remember that since this has to be negative, one of these factors has to be negative. So I'll try 3 first on one, and I'll try 6 as the other negative. Okay, so 6 times -3 is -18. -3 plus 6 together is 3. Did I get it? Yep. So this one is the pair that I'm going to use. So again, what am I doing? I am factoring out this trinomial into 2 binomials, knowing my first term is going to be x in each one, and that is given because we just have an x squared out here. That's why I know that's going to be x. Then I know that -3 is going to be one of my constants, and +6 is going to be the other one. Because again, doing a quick FOIL, 6x minus 3x is 3x. 6 times -3 is -18. Okay? Again, why? Why are we doing this? Because of this question right here. What values could x be in number 4 in order for this equation to equal 0? Well, this is even a little bit harder to see than we did last chapter or last section, because they're saying x squared plus 8x plus 12. What could we plug in there to make it equal 0? Well, guessing and checking on this one is going to be kind of disastrous. But remember what we just did. We're going to go ahead and factor it and look at each one of those factors, because when we factor, look what happens to our degree. We go from a degree of 1 to 2 binomials that have a degree of 2 to 2 binomials that have a degree of 1. And we are much more comfortable solving an equation that just has that degree of 1. So what was the rule last chapter or last section? Last section said take each one of these products, set it equal to 0, and solve. So if I subtract a 6 over, I know that I could put a -6 in there, okay, which would be 36 minus 48, which is -12, plus 12 is 0. So that works. I could also put a -2 in there. Oops. Does that one work? Okay, 4 minus 16 is -12, plus 12 is 0. Yep, that does work. So again, when we are dealing with that second degree, we are going to have 2 answers about 95% of the time. So still factoring to get rid of that second degree in order to just focus on a first degree so we can go ahead and solve. Okay, so with that in mind, go ahead and get out the notes and vocab for the section. Okay, the objective of this section is to solve quadratic equations by factoring. Solving means we are trying to find the value of x. We're also going to write one variable quadratic equations to represent a context. So again, getting to that real world application. I actually went through this whole first page, but I did include it because again, maybe worded a different way might make it a little bit easier to understand. Okay, again, looking at those symbols is kind of important because a lot of times they don't throw in numbers. They like to use those variables because it does represent every context. Then they give a good example there. Okay, so again, I'm not going to go over that because we looked at it in the introduction. We're going to jump right into example 1. Again, factoring this. So what we found out is that when we factor this, the big question is what times what gives us the outside number, added together gives us the inside number. So right away, we're going to set up a little factor sum. And we're going to put down our goals. Our goal, the two numbers multiplied together should give us 20, and added together should give us 9. And we're just going to go through all of the different 20 factors. Okay, again, I know that if I did 20 and 1, that's too big. So I'm going to go ahead and do 2 and 10. 10 times 2 is 20. 10 plus 2 is 12. And again, our goal is 9, so that didn't work. Okay, 20 divided by 3 doesn't work. 20 divided by 4 does. So I know that there's a factor of 4 and 5. What's 5 plus 4? 9. So there it is. Those are the two numbers that we are going to use in our two binomials. So when we set up our factors, we know that we are going to have two binomials. We know the first term is going to be x. We know the second term is always going to be these two numbers here. That is a positive 4 and a positive 5. How do we know that? Because we understand the FOIL method. We understand our firsts are always going to be this one. Our lasts are always going to be our last term in our trinomial. And what I call the OI, the outside and the inside, added together is going to be that middle term. Okay, so we understand that pattern, that these two numbers multiplied together here, added together here. Okay, so use that little table to help you stay focused on your factors, and go ahead and factor guided practice 1. Okay, the kind of fun thing about this concept is students that know their factors really think this is a challenging, fun game where they're going to see how fast it is they can realize what two numbers multiplied together give them 24, added together give them 11. Other kids really struggle because they don't know their factors. So this factor table really does help them. And again, just tell them, go down the line, divide by 1, divide by 2, divide by 3, until you get something that works. If you don't like my smiley faces, I'm sorry. You can go ahead and do an X or a check instead. Okay. Right away, 1B worked as soon as I put that in standard form. Standard form is a good deal, especially when we're looking at how to factor. So again, highest degree first, not highest leading coefficient, but highest degree. So t squared plus 10t plus 9 gave us a factor of 9 and a sum of 10. This, I think, is the first time that we've seen a sum that's bigger than our factor. But 1 times 9 is 9, added together 10. So that one actually did work. Okay, those were all nice because they were all positive. Now we're going to change it up and look at negatives. All right, when B is negative and C is positive. This is a different one because if our middle term is negative, that means that both numbers are negative. How do I know that? Because I know that, again, we're multiplying these two numbers out here. The only time that we're going to get a positive multiplying two numbers is if both of those numbers are positive or both of those numbers are negative, because a negative times a negative gives us a positive. A negative plus a negative gives us a negative. Okay, so look at those clues when we're dealing with negatives. This does really help us out because then we don't have to go through quite so many different options. So factor in sum. Our factor, we want to have a positive 12, but our sum a negative 8. So again, let's go through all those factors of 12. I know that it's not 1 and 12. That's too big. Let's go ahead and try 2 and 6. But remember, both of these numbers are negative. So a negative 6 or a negative 2 times a negative 6 is a positive 12. What sum is that? Look at that. We were lucky. We got it right off the bat. Okay, so how do I write that? Remember, to start this, go ahead and put out your two binomials, knowing that there's our first term right there. X times x is x squared. Negative 2x plus a negative 6x is negative 8x. Multiplied together gives us a positive 12. Okay, getting comfortable with those clues really does help. So with that clue in mind, go ahead and factor guided practice 2. Okay, having to write 2a in standard form, we were looking at a factor of 21, a sum of negative 22, that negative told us that both of our constants had to be negative. Okay, right away we caught that one. 2b, we had a factor of 28, sum of negative 11. Had to get through one factor in order to find that negative 4 and negative 7 that would work. Okay, so same concept, just looking at that nice little tip about the negative. Okay, this one's a little bit different. When c is negative, which is the constant term, we know that just one of our numbers is going to be a negative because negative times a positive will give us that negative. So these are probably the most challenging because there's so many different options that we have to go through. So again, we're looking at factors and sums. Our factor has to be a negative 15 and our sum has to be 2. Okay, so I'm going to skip 1, negative 15 divided by 1. Negative 15 divided by 2 doesn't work. Negative 15 divided by 3 does. So I have 3 and 5. But remember, I have to write it twice because I have the option of making that 3 negative or making that 5 negative. Okay, so negative 3 plus 5 is 2. Look at that. Right away we caught it. And then 3 plus negative 5 is a negative 2. So that did not work. Okay, so we know it's these two numbers. So again, I set up my two binomials. X is going to be that first term always in this section because we have nothing out in front of that x squared. I have a negative 3. I have a positive 5. So question, what happens if I wanted to put x plus 5 first, then x minus 3? Does that change the answer? No, it doesn't, because we're multiplying. You remember, with multiplication, we can flip-flop them. That would be fine. When we start looking at these, those students that catch on quick with factoring are going to realize, okay, so if I have a negative here and this is a positive, that means that my smaller number is going to be negative, because a smaller negative number plus a bigger positive number is going to give me a positive number, if that makes sense. So let's look at this one. Now I have two negatives. Okay, still we're looking at that negative right there, knowing that both, or that one of my terms is going to be negative, because a negative plus a positive is going to give me that negative. So my goal is a negative 18 as a factor and a negative 7 as a sum. Okay, 18 and 1, too big to be anything around 7. So I'm going to go ahead and try 2 and 9 twice. 1 with the negative 2, 1 with the negative 9. Negative 2 plus 9 is a 7. Close, but I have to have a negative, so that doesn't work. 2 plus a negative 9 is a negative 7. So there it is, right here. Which means, again, in my binomial, x is first, a positive 2, and a negative 9. So again, some students see that, all right, well, if I have two negatives, that means that my bigger number is going to be negative, because a smaller positive plus a bigger negative is going to give me a negative number. That negative will trump the positive. Okay, so other little tips and tricks that you can use. Otherwise, set up that factor sum table and go for it. All right, give guided practice 3 a shot. Okay, numbers with a lot of factors get tricky, especially when we're dealing with these type of negative numbers where we have many different options. Finally, I ended up with a positive 4 and a negative 6 to factor 3b. Okay, again, the big question, why? Why are we even factoring these? And this is the answer. So we can solve these quadratic equations. So we can figure out what we can put in for that variable in order for this equation to answer true. So if you remember from last section, we're actually doing the same thing. Remember that we had 3 different rules. We had a set equation equal to 0. And then we had to factor. This time we are going to factor into two binomials. Last time it was mostly a binomial and a monomial, but now we have two binomials. Set each binomial equal to 0, and solve. Okay, 3 steps. Sometimes some of the steps are there for us, other times not so much. So set equation equal to 0. Looks like they didn't do that for us, which means that we're going to have to subtract this 27 over. So we end up with x squared plus 6x minus 27 equals 0. Step 1, done. Step 2, now we have to factor into our 2 binomials. So understanding I'm dealing with a trinomial, which means that I have to do my factor sum. My goal is to get 2 numbers that multiply together to give me negative 27 and added together to give me 6. Okay, so let's go for it. We've got 27 divided by 2 doesn't work, but 3 does, so we have 3 and 9. Remember, because he's negative, I have to have 2 different options here, because I know each one of those terms could be negative. So negative 3 plus 9 does give me negative 27. Negative 3 plus 9, I'm sorry, what did I say? Negative 3 times 9 gives us a negative 27. Negative 3 plus 9 gives us a positive 6. So that one worked. This one wouldn't have because it had a negative. So these are the 2 constants that I'm going to use. So I have x minus 3 and I have x plus 9. And again, I'm going one step further because I want to set this equal to 0. So over here, it says set each one of them equal to 0 and solve. Okay, so I end up having x minus 3 equal to 0. So I know x equals 3. I have x plus 9 equal to 0. So I know x equals negative 9. And I'm running out of room. Yikes, I apologize. So let me get rid of some of this stuff here. Okay, so steps that we already know. Remember that most of the time we are going to get those 2 solutions, that in this situation 3 and negative 9 could be plugged into that equation in order for it to ring true. Okay, use those 3 steps to go ahead and solve guided practice 4. Okay, using those tips and tricks from earlier could be beneficial. Realizing this one has 2 negatives, so I know that my bigger number is going to be the negative. Over here, my middle term is positive, so I know my bigger number is going to be positive. One thing, some students, once they get to right here, they see the answer as negative 3 and 6. That's not true. It's going to be the opposite of that, because remember, we take each one of these and set it equal to 0, because we want to figure out what we can put in for x in order to cancel that out. So you can quickly see it's always going to be the opposite of this, so you can get to this step right here and realize, oh, opposite of negative 3, I know my answer is going to be 3. Opposite of positive 6, I know my answer is going to be negative 6. Okay, so don't let them stop here and keep having them say that the answer is exactly those factors. It's always the opposite of the factor. Okay, and here comes the story problem. It says that Ling is designing a poster. The top of the poster is 4 inches long, which they show right here, and the rest of the poster is 2 inches longer than the width. So here's the rest of the poster, and this is the length. Here's our width, so we know this piece right here is W plus 2, the width plus that 2. If the poster requires 616 square inches of poster board, we're supposed to find the width W of the poster. Wow. Well, I know square inches, we're dealing with area. So right away, I'm going to write down the formula that I'm going to deal with. Area equals length times width. Then I'm going to figure out what I know. Do I know my length? Well, my length is W plus 2 plus 4. So I know my length is W plus 6. My width is just W. Okay, so my area as an expression is W times W plus 6, which is W squared plus 6W, because I'm distributing this through. But now they give me something else. They say that if the poster requires 616 square inches of poster board. So I actually know that my area is 616. So I know that I'm going to rewrite this as W squared plus 6W equals 616. Okay, so now this is starting to look like what we already know. Looks like we are solving a quadratic equation. Let's go back to our rules. Rule or step number 1, we're supposed to set this equal to 0. So it looks like I'm going to have to subtract a 616 from each side. I have W squared plus 6W minus 616 equals 0. Whoa, Nelly, that's a big number. So with this, again, we are still factoring this because we can't solve for W until we have two binomials that we can look at, which is an exponent of 1. So our factor has to be negative 616, and our sum has to be 6. Okay, so this is where you just grab that calculator and go crazy. Divide by 2, divide by 3, 4, realizing that it's going to be bigger than 2's, 3's, and 4's because our sum is only a small little 6. So I found out that 616 divided by 14 is 44. So let's try 14 and 44. Okay, I know that those two together will give me that 616. I know that one of them has to be negative because I have a negative number there. Well, 44 minus 14 is 30. So that didn't work. That's not even big enough. And this is negative 30. Okay, well, let's try double 14 then. Let's try 28. So 616 divided by 28 is 22. So let's try 22 and 28 and see what happens. Okay, and honestly on this one, remember our little clue? Since he's positive, I know that this bottom one isn't going to work because again, it has to be the smaller number that's going to be the negative in order to get that positive. So to save me some time, all right, let's go ahead and figure out what 22, negative 22 plus 28 is. Look at that, 6. Did we do it? Yep. Okay, but the question is, what did we do? So we found the two factors that are going to work in our binomials. So I have a W minus 22, I have a W plus a 28, and I'm setting that equal to 0. So since I'm setting that equal to 0, here, you know what? I'm going to move this guy over so I have room to work. Okay, now I'm going to look at each one of these pieces. I have W minus 22 equal to 0, and I have W plus 28 equal to 0. Okay, and I'm going to go ahead and solve this. So it looks like I have W equals 22, and I have W equals negative 28. Okay, so we are all in a crazy frenzy to solve this. Let's go back up and make sure we understand what we're talking about or what we're trying to answer. We're trying to find the width of the poster. Width is W. We found W. The only problem is we found two answers. So let's look at this real world story problem. We are looking at the width of the poster. Which one of these does not make sense? The one that's negative. We cannot have a negative width. So I am going to say that this cannot be our answer. So it must mean that our width is 22 inches. Inches, right? Inches. So 22-inch width. Out of all of that, that is how we found that that width is 22. You know what some students do? They go ahead and guess and check until they find a correct answer. You know what? It doesn't say any different, but to understand the complete correct steps on how to do that, this would be the best way to do it. Okay, yes, a lot of steps, especially if we're dealing with big numbers like that. But go ahead and try it with guided practice 5. Okay, another big factor type of problem. A parallelogram looks like this to someone who's a better artist, but we know its area is just base times height. They tell us the height was 18 less than the base, so this is what I set up. I know that my area is 175, so going through all of my steps, plugging it into the formula, distributing, setting it equal to 0, factoring. I was pretty lucky my first time around because I saw 75 and I know that 25 is going to be a factor of anything that ends in 75. Okay, I also use that clue that he's negative. That means that my bigger number has to be negative. So I factored that. I set them both equal to 0. I realized I was dealing with a story problem, so that -7 I had to cancel out right away. So I knew B equal 25 centimeters. I was very close to circling that and saying done, but then I made sure to come back up here and they said, what is the height? So I would have circled the wrong thing. Well, I know that the base is 25. I know the height is 18 less than that. So final answer, our height is actually 7 centimeters. Okay, so the biggest thing is dealing with those factors and sums, getting very used to your factors and making sure that you use those clues with the negatives. Okay, another long section, but go ahead and give the assignment for this section a shot.